Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 6 video on the chapter of exponents where I will solve sample test paper number 1 which I have discussed before that for at the end of every chapter I will prepare 2 sample test paper which will be MCQ questions, 15 MCQs, and ideally you should be able to solve them in 45 minutes. The questions in this test paper 1 and 2 will be relatively harder from the questions that we do from the textbook of author R.S. Aggarwal. So try to attempt all the questions in each test paper yourself first, and if you are stuck, you can always refer this solution video. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, or if you are visiting my channel or seeing this video for the first time, I strongly suggest that and request that you subscribe to my channel, support me, and if my videos are beneficial to you, then support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the sample test paper number 1 on the left hand side, and on the right hand side I will solve the problem. While solving the problem, I will mention all the concepts that I am applying wherever necessary on the right hand side. Okay, so let's start solving the problem. The first problem says that, so it is a kind of an equation is given and we have to solve the value of n, which is in the power, which is present in the power on the right hand side of the exponent, present in the exponent or power or index of the exponential term. So we are given that 3 to the power 4 divided by 3 to the power minus 6 is equal to 27 raised to the power n plus 3. Now the general strategy of solving this kind of equation, to solving for n, sometimes it will be x, is to simplify both the left hand side and the right hand side in the exponential form, and so that both the left hand side and the right hand side have the same base. The base on the left hand side and the right hand side will be same. So on the left hand side it could be say m, on the right hand side it could be n. Now m or n, in the powers m and n, you will find the unknown x or n, and you have to solve that. So the basic idea is that if we have this kind of equation, we will equate the powers. We will have m equals to n, and from this equation we will solve the unknown. Now in the given problem, you may not see immediately that the base on both the left hand side and the right hand side is same, or you have to do a little bit of simplification. So the left hand side, if I apply the concept that x to the power m divided by x to the power n is equals to x to the power m minus n, I will get 3 raised to the power 4 minus 6 equals to, now on the right hand side I see the base is 27, but I need base 3 because on the left hand side all the base I can see that the base I will get is 3. So 27 I can write it as 3 cube, and I have it is raised to the power n plus 3. Now the left hand side becomes 3 to the power 4 plus 6, that is 10, equals to, now again I will apply the formula that 3 cube whole raised to the power n plus 3 is nothing but 3 raised to the power 3 multiplied by n plus 3. The concept applied is that if we have an exponential term of the form x raised to the power m, where x, whenever I'm using x on the right hand side, please note that it is a non-zero rational number and all the powers mn are integers. That is, it could be positive integers, negative integers, or it could be even 0. Now if I have x to the power m and this whole term is raised to the power n, I know this is equal to x to the power, the product of the powers, that is m into n. So this implies, now I have, so this is 3 raised to the power 10 equals to 3 raised to the power 3 into n plus 3. Now I can see the bases are different on both sides, which is 3. I will equate the powers. So this equals to 10 equals to 3 into n plus 3. Now if I expand or open the right brackets on the right hand side, I will get this is 3n plus 9. So this implies I have the linear equation in n, that is 10 equals to 3n plus 9. So this will, from here I can say I need to solve n. Now I hope you are all aware of, you have completed the chapter in class 7 about linear equations in one variable. So this should be very easy for you. So 3n equals to 10 minus 9 equals to 1. This implies n equals to 1 by 3. So n equals to 1 by 3. So the correct choice is A. So while I am solving the problem, you can pause the video and take a screenshot of the solution for your future reference if you think it will help you. So I will pause for a couple of seconds after completing a solution so that you can take screenshot. And if you find any kind of difficulty in following my theory videos or even any method in solving the problems of any chapter, please feel free to contact me in the comment section. I will do my best to help you out, to address your query or any kind of help you need. Okay, let's do problem number 2. Which of the following is not the reciprocal of 2 by 3 raised to the power 4? Which of the following is not the reciprocal? Okay, so what is reciprocal of 2 by 3 raised to the power 4? Let's find that out. Reciprocal of 2 by 3 raised to the power 4, we know by as per the notation, we know the notation is the given number is 2 by 3 raised to the power 4. Its reciprocal will be this term whole raised to the power minus 1. Now this is equal to, you know that we have two layers of powers. The first power is 4 and another power is minus 1. So this will be equal to 2 by 3 raised to the power 4 multiplied by minus 1. The power gets multiplied. Now there are some concepts that I will be applying more than once in solving the problems. So I don't think I need to write them again and again. So like in this problem number 2, I have applied the concept of this concept. So I hope you will understand which concepts I am applying. So whenever I will not write it down, if I have already used that concept in some previous problem, I will just highlight that from my side notes. So on the right hand side, I will discuss about the concepts being applied. We have this reciprocal of 2 by 3 raised to the power 4 is nothing but 2 by 3 raised to the power minus 4. Okay, which is this is what? This is nothing but the power is negative. When the power is negative, when the power is negative, this is nothing but 3 by 2 raised to the power 4. This is a very important laws of exponents. So if you have x by y raised to the power minus m, this is nothing but y by x raised to the power m. This is a super important laws of exponents. Okay, so I have this. So finally the reciprocal of the given number will be 3 by 2 raised to the power 4, which I can also write it as 3 to the power 4 divided by 2 to the power 4 in the rational form. Now let's check what are the options given. The first option A is clearly this one, 3 by 2 raised to the power 4. So it is correct. It is not. It is not. We have to choose which is not the reciprocal. That is the incorrect result we have to choose. So A is the correct choice. A is a not the correct choice, but the value given in A is indeed the reciprocal of the given number. What is B? B is 3 by 2 raised to the power minus 4. No, it cannot be. If this is the correct answer, then 3 by 2 raised to the power minus 4 cannot be the reciprocal. So definitely the choice, immediately we will say the choice we have to select is B, because 3 by 2 raised to the power minus 4 is not the reciprocal of 2 by 3 raised to the power 4. Now just to check whether option C and D are also the reciprocal of the given number, D you can clearly see that it is 3 to the power 4 divided by 2 to the power 4. Now what is C? C is 2 by 3 raised to the power minus 2 by 3 raised to the power minus 4, which is this one. So the correct answer is the correct choice we have to select is B, which by the way is not the reciprocal of the given number. Okay, let's do problem number 3. The value of, okay, so we are given an expression, we have to evaluate. This is also a very standard pattern of question. You must be very well versed with in solving this kind of problem. So you will be given some addition or subtraction of some exponential terms, and those exponential terms will actually be some reciprocals. Like in this problem we have reciprocals mean the power is minus 1. So what is this? This is the reciprocal of the difference of two reciprocals. The first reciprocal is this one, the second reciprocal is this one. So it is, we have to find the difference. Now what is the reciprocal? The base of the first reciprocal is again a difference of two exponential terms, which are reciprocal of 7 and reciprocal of 8. I hope you got the idea. So anyway, these are very easy. This is a very easy questions. It is not at all hard if you understand what is going on. If you understand the power and the base properly, this should be no problem. It is just that when you are given a difference or addition of two terms where each term is the exponential form, you have to convert those each exponential term into rational number, rational form. Okay, so the bracket which is the base of the first term will be, it is 7 to the power minus 1 means reciprocal of 7, that is 1 by 7, and I have minus 1 by 8, and whole I have raised to the power minus 1. Similarly I will have 1 by 3 minus 1 by 4 whole raised to the power minus 1. Now I have to simplify what is 1 by 7 minus 1 by 8. This will be 8 minus 7 by 56 and raised to the power minus 1. Over here we will have 4 minus 3 divided by 12 and raised to the power minus 1. So this is what 1 by 56 whole raised to the power minus 1, and this is 1 by 12 whole raised to the power minus 1. Now what is 1 by, so again 1 by 56 raised to the power minus 1 means the reciprocal of the base. So whenever you have like this, what is this? X is any rational number, of course a non-zero rational number. Whenever we have this is nothing but you take the reciprocal of the base. The base is x, so its reciprocal will be 1 by x. Similarly, if you have a expression of the form like this, 1 by x, its reciprocal, this will be x. Reciprocal of 1 by x is x. So these small things you should immediately able to figure it out. Okay, so this is nothing but 56 minus 12. This is how much? 44. 44. Okay, so I will okay, so 44 is the result, or is the value of this expression, and The correct choice is A. The correct choice is A. Okay, let's do problem number 4. The standard form for, so we have to find the standard form for 0.000040 and 64. What is the standard form of this? Now the given number is a very small number, and we have already discussed the numbers in standard form and how to express large numbers and small numbers in standard form. There are some steps I have discussed. So if you have not watched all my previous videos on the chapter of exponents, I highly suggest and request you that you please watch them. It will give you a really good idea of the concepts of exponents, about all the concepts and topics that are discussed in the textbook of author R.S. Aggarwal. You will really benefit from those videos. So this is a very small number. So what are the steps? First, we know that a number in the standard form is written is like x multiplied by 10 to the power 10 to the power x multiplied by, so this is a side note, a number in standard form is x multiplied by 10 to the power y, where x is a decimal number. It should lie between 1 and 10, that is less, it should be less than 10 but greater than equal to 1, and y is a is an integer. Y is an integer, and you can also consider that y is not equals to 0. Usually y is not equals to 0, because if y equals to 0, then 10 to the power 0 is 1, it will make no sense. Okay, so this x is always greater than equals to 1 and less than 10. We have to express this number in this form. So what do I need? I need x and y. So first we find y. The first step is to find y. What will be y? Y will be the number of digits to the right hand side of the decimal point up to the first non-zero digit. So those digits will be up to 6. The 6 is the first non-zero digit to the right hand side of the decimal point. So I will consider I will find what is the number of digits to the right hand side of the decimal point up to the first non-zero digit. So there are 4 zeros and the 6 digit 6, so y will be 5. Now I have to find x. What will be x? X will be, you consider the given number, the decimal number, very small number, and you ignore the decimal point. If you ignore the decimal point, it becomes a whole number. The whole number will be 64. If you ignore the decimal point, the whole number will be 64, and in that whole number 64 you place a decimal point after the leftmost digit, so it becomes 6.4. As a final step, I have got x, I have got y, so the number in standard form will be, now please bear in mind, whenever we are expressing a very small number, given small number in standard form, the format will be x to the power x multiplied by 10 to the power minus y, not y. Now this is on the right hand side, what I have written is 10 to the power y. In that y, please note that y is an integer, so it could be positive integer, it could be negative integer. It is not generally used, usually it is not 0. So either positive integer or negative integer. For expressing a very small number, the y will be negative, and for expressing a very large number, the y will be positive. So in this, since we are expressing a very small positive number, the y will be negative. So this becomes, now x is 6.4 multiplied by 10 to the power minus 3, and we do not have 10 to the power minus 3 y. Y is why I am writing 3, 10 to the power minus y, so it will be 10 to the power minus 5. So this is the number in standard form of this given small number. So the correct choice is D. Okay, let's do problem number 5. So we are given an equation. Okay, we have to find the value of y. Now this is also a kind of that pattern of question where we have to find some unknown from the given power. So it's an equation. On the right hand side, the left hand side will be some terms in exponential form, and it will have a base. On the right hand side will also be a term in the exponential form. In the exponential form, by exponential form, whenever I will say a term in exponential form, you must understand that I am talking about something like this x to the power m, where x is a non-zero rational number and m is an integer. So on the right hand side, so in this problem, so what is given, let's write it down. P to the power a plus b raised to the power multiplied by p raised to the power b plus c multiplied by p again raised to the power c plus a equal to, on the right hand side we have p 1 by p raised to the power minus y. So the idea is to convert both the terms, both the LHS and the RHS in the exponential form, so that the base remains the same, base is same. Then we will equate the powers. Now the left hand side, if you know that we are the left hand side is a multi product of three exponential terms. If I consider we have p raised to the power a plus b multiplied by p raised to the power b plus c. If I do this first and let the remaining terms be as it is, in the right hand side I know that 1 by p is the reciprocal of p, that is p raised to the power minus 1, and I have whole raised to the power minus y. Now if I do the product of the first two terms on the left hand side, we can see the base is same. The product of first two terms, each term is an exponential form where the bases are same, p. So this will be p into p raised to the power a plus b plus b plus c. So I have applied the concept of x raised to the power m multiplied by x raised to the power n is equal to x raised to the power m plus n, and I have product p raised to the power c plus a equals to, now on the right hand side I have p raised to the power minus 1 and that whole is raised to the power minus y. So I can write it as p raised to the power, the power will be the product of the two powers, that is minus 1 multiplied by minus y. This implies, now I can again see the left hand side is a product of two exponential terms, where each exponential term the bases are same p. So this will be p raised to the power, now this thing I should have, okay, so this is now the first on the left hand side, the product of we have product of two terms. The first term is p raised to the power a plus b plus c, which is nothing but a plus 2b plus c. And now we have the second exponential term is p raised to the power c plus a. So we will add c plus a. And on the right hand side we get p raised to the power minus 1 multiplied by minus y is y. So this implies, if I simplify the power on the left hand side, this will be a plus 2b. So I can see this is twice a plus twice b plus twice c. So this is 2 into a plus b plus c. We have p raised to the power y. Now I can see the both hand side are exponential term where the bases are same p. So I can equate the power. So this will be 2 into a plus b plus c equals to y. So y equals to twice of a plus b plus c. So the correct choice is D. The correct choice is D. Okay, let's do problem number 6. We have to simplify. Okay, so it's a division of two terms where each term is is in exponential form. So the dividend is 3 by 8 raised to the power 2, and this whole raised to the power minus 3 divided by, the divisor is 4 by 9 raised to the power 4. Okay. Now, so this is equal to, first let's simplify the dividend. I mean, if you have this kind of expression, this is the dividend and this is the divisor. So if I simplify the dividend, is I can see is in exponential form. It's an exponential term, and we have two levels of power. The first level of power is 2, and the second level of power is minus 3. Now whenever I speak two levels of power, I mean if you have an expression of the form x to the power m and this whole is raised to the power x n, then I might say that this expression has two levels of power, and the first level of power is m and the second level of power is n. Okay, and this, we know that this is equal to x to the power m into n. So if we apply this concept, I will get the dividend will become 3 by 8 raised to the power 2 multiplied by minus 3, and we have divided by 4 by 9 raised to the power 4. This is equal to 3 by 8 raised to the power minus 6. Now divided by can be by a number, can be replaced by multiplication of the reciprocal of the divisor. The reciprocal of the divisor. So the concept is, if you have something like x divided by y, where x and y are some rational numbers, it could be in the rational form or in exponential form, whatever. This is nothing but x multiplied by the reciprocal or the multiplicative inverse of y, that is y raised to the power minus 1. This concept I have applied in the last step. So this is equal to, now 3 by 8 raised to the power minus 6 is nothing but 8 by 3 raised to the power 6. Again the concept applied is x raised to the power minus m is equal to 1 by x raised to the power m. This we have product of 4 by 9, it becomes 4 by 9 raised to the power, we have 4 multiplied by minus 1. This is equal to 8 by 3 raised to the power 6 multiplied by 4 by 9 raised to the power minus 4. This is equal to 8 by 3 raised to the power 6 multiplied by 4 by 9 raised to the power minus 4. The power is negative, so this will be 9 by 4 raised to the power 4. So now at this stage we have to break the exponential form into rational form. That is, by breaking an exponential form into rational form, or you can say converting a rational form into converting an exponential form into a rational form, means if you have something like this, x by y raised to the power m, this is nothing but x to the power m divided by y to the power m. Now you can, so we have x 8 raised to the power 6 divided by 3 raised to the power 6 multiplied by 9 raised to the power 4 divided by 4 raised to the power 4. Now if you have this kind of expression where you have some exponential terms, always try to have a similar basis, like 8 raised to the power 6, 8 raised to the power 6 and 4 raised to the power 4. I can convert 8, the bases 8 and 4 to bases 2, but I cannot convert the base 8 to 4. I need to have common base. I need to have common base, create common base. Now 9, I know I can make the base 9 3 square, but 8 I cannot do, I cannot convert the base 8 to base 4, but I can convert both the base 8 and 4 to base 2. So I will do that. Now 8 is 2 cube and whole to the power 6. 3 is 3 to the power 6 we have, and 9 to the power 4 I can write it as 3 square whole to the power 4, and 4 I will write it as 2 square whole to the power 4. So now this becomes 2 cube raised to the power 6 is nothing but the powers will get multiplied. So I have 2 to the power 18 divided by 3 to the power 6 multiplied by 3 square whole raised to the power 4 is nothing but 3 raised to the power 8 divided by 2 square raised to the power 4 is nothing but 2 raised to the power 8. So I can see now all the exponential terms, I can see some common bases 3 and 2. So I will merge the common bases, that is I will have 2 to the power 18 divided by 2 to the power 8 multiplied by 3 to the power 8 divided by 3 to the power 6. So this becomes 2 to the power 18 minus 8 multiplied by 3 to the power 8 minus 6. Using the formula x to the power m divided by x to the power n is equal to x to the power m minus n. So this is equal to 2 to the power 10 multiplied by 3 square. So the correct choice we can see is B. Okay, let's do problem number 7. The standard form of number of seconds in a week is the standard form of number of seconds in a week. Oh, so the number of seconds in a week will be obviously a very large number. So okay, so number in a week, so how many seconds are there in a day? So number of, let's see, number of seconds in a day is how many hours we have? 24. So 24 hours. Now 24 hours is how many minutes? 60. And this minutes is how many seconds? 60. So this we have to find. 24 multiplied by 36. What is happening with my machine? 3600. I guess this is kind of 8 4. Let me find it out. 36 multiplied by 24. 24. 144 multiplied by 612, 7. So 4, 6, 8. So this is 86400. So number of seconds in a day is this. So this implies number of seconds in a week will be, we have 7 days in a week. So this will be 86400 multiplied by 7. This is how much? We have to multiply 864 by with 7. 28, 42, 44, 56, 60. 604800. This much. Really? This many seconds we have in a week. So we have to write the standard form of this number, this very large number. So how do we do? What are the steps? First we put a after the first step we put a decimal point after the leftmost digit in the given number. So this becomes 6.04800. Now we have to find y, that is step 2. What will be y? Y will be the number of digits to the right hand side of the decimal point in the number you obtained after step 1. After step 1 we got 6.04800. So the number of digits to the right hand side of the decimal point is, how many digits are there? 04800. So 5. Now I will find x. What will be x? Step 3 is to find x. What is x? X is what was x? How do we find x? Oh, x will be the number you obtained after step 1, that is 6.04800, the same number, but you ignore all the trailing zeros. These are the trailing zeros. You know, in a decimal number, in the fraction part, all the trailing zeros are useless. They are not required. So x is 6.048. So we got x and we got y, and we know that the number in standard form will be x multiplied by 10 to the power y. This is equal to 6.048 10 to the into 10 to the power what was y? 5. So this is the number in the standard form of the number of seconds in a week. So the answer is 6.048 10 to the power 5. Okay, so the answer is choice A. Answer is choice A. Okay, let's do problem number 8. Usual form of we are given a number. This is a very small number because the power of 10 is negative. We are given this number and we have to find this, convert this number into standard form, that is without, in normal form, the decimal form, that is without any factor of power of 10. Okay. Now, how do we do this? We will have a power of 10, and the power of 10 could be positive or negative. In this case, it is negative, so this means the number in usual form will be actually a very small number. So 7.63, first you convert this decimal number into fraction form so that the denominator will be powers of 10. Now 7.63, if I want to convert this into fraction form, I know it will be the given number as a whole number, ignoring the decimal point, that is 763. The numerator will be this, and divided by 10 to the power will be equal to the decimal places of the decimal number, that is 7.63. The decimal places is 2, so 10 square. Now I have this multiplied by 10 to the power minus 4. Now I will merge the two exponential terms with the base 10, that is 10 to the power minus 4 divided by 10 square. I will evaluate this. This is equal to 763 multiplied by 10 to the power minus 4 minus 2. So the concept again applied is x to the power m divided by x to the power n is equal to x to the power m minus n. So this is equal to 763 multiplied by 10 to the power minus 6. Now this is this is nothing but you have to play around with the decimal places, decimal point. Basically you are dividing the number 763 by power of 10, that is 10 to the power 6. You have to divide the decimal number 763 by 10 to the power 6. So how do we do this? We just shift the decimal places in the number 763 to the left by 6 places. Why 6 places? Because we are dividing by 10 to the power 6. So 763, if you consider it as a decimal number, this will be 763.0. So I have to shift this decimal point to the left hand side by 6 places. So the way visually I do is 1, 2, 3, 4, 5, 6. The last jump will be the place of the decimal, and in between jumps, if there are no digits, I will fill it with 0. So this becomes 0.000763. So 763 divided by 10 to the power 6 becomes 0.00030 This is the number in usual form. So the answer is choice B. The answer is choice B. Okay. Let's do problem number 9. This is again a solving for an unknown in the power. So we have the equation given is 3 raised to the power 2x minus 1 plus 7 this whole divided by 5 equals to 50. Now sometimes in this kind of problem you will not immediately see the right hand side as a base in the exponential form. In this problem the right hand side is 50 and we cannot really convert this 50 into an exponential form. So and also you can see that the left hand side, the LHS, is also not in an exponential form. Even though we have the 3 to the power 2x minus 1, but we have plus 7 and divided by 5. So in this kind of problem you just simplify, and then finally you have to figure it out what is 3 raised to the power 2x minus 1. From there you have to the power, the unknown, is in the exponential term, which is 3 raised to the power 2x minus 1. Somehow from this equation, manipulating it, simplifying it further, I have to arrive to an equation of the form where I will have this equal to some number on the right hand side, some constant, and then this a I have to somehow convert it into exponential form like 3 to the power some m, and then I will equate 2x minus 1 equals to m. So this is the general strategy. Okay, so now I can see that this implies I know that this is 2x minus 1 plus 7 divided by 5 means multiplied by 1 by 5 equals to 50. So this implies that 3 raised to the power 2x minus 1 plus 7 will be equal to 50 multiplied by the reciprocal of 1 by 5. Why I am writing this? If you have something like a multiplied by b equals to c, then this will imply a is equal to c multiplied by the coefficient of a was b, multiplicative inverse of b. If you want to find a from this a into b equals to c, if you want to find a, then it will be the right hand side c multiplied by the multiplicative inverse of the coefficient of a. Also if you want to find b, b will be equal to the right hand side multiplied by the multiplicative inverse of coefficient of b, that is a inverse. This is the concept. So I use this concept to find 3 raised to the power 2x minus 1 plus 7, its coefficient was 1 by 5. So I multiplied the right hand side with its multiplicative inverse. So this is equal to, now what is 50 multiplied by 1 by 5, its multiplicative inverse. So 1 by 5 raised to the power minus 1 means reciprocal of 1 by 5, which is 5. So this is equal to 250. So this implies on the left hand side I can easily open the brackets and I will get 3 raised to the power 2x minus 1 plus 7 equals to 250. This implies 3 raised to the power 2x minus 1 is equal to 250 minus 7. This is equal to 243. Now definitely 243 must be some power of 3. Now what is that power of 3? If you can do it orally, fine. Otherwise you will have to prime factorize the number 243. Keep on dividing with 3. This will be 81. Now 81, you know clearly that 81 is 3 to the power 4. So definitely 243 will be 3 raised to the power 5. So now we see, now we have in the equation, the left hand side is the exponential term with base 3, the right hand side is also an exponential term with base 3. Now we can equate the powers, so we get 2x minus 1 equals to 5. This implies this is a linear equation and one variable in x. You should be able to solve it very easily. This is 2x equals to 5 plus 1 equals to 6. This implies x equals to 6 by 2, which is 3. So the value of x is 3. And it is not O. The problem is from the given equation you have to find the value of x to the power minus 2. Okay, so we have to find x to the power minus 2. X is 3. X we have found to be 3. This implies x to the power minus 2 is equal to 3 to the power minus 2. This is 1 by 3 square. This is equal to 1 by 9. So 1 by 9 is the answer, value of x to the power minus 2. Hence the correct choice is B. So whenever you are solving a problem, always read the problem carefully, what is given and what is asked. That is a very first step, very important step. If required, read the problem 2 or 3 times. Okay, let's do problem number 10. Let's do problem number 10. Which of the following is true? Oh, okay, so which of the following is true? Okay, so we have to check every single choice individually. So what is okay, so 1 by 25, it is multiplied by 5 to the power n is equal to 1 by 25 is what? 5 is 5 square. So we have to convert whatever the expression is given in terms of exponential form with the base 5. We have 5 to the power n. So this is nothing but 5 to the power, not minus n, but n. This is what? 5 to the power n minus 2. So which of the following is true? So straight away we found that the first choice is true. The first choice is true. So definitely the answer is choice A. The answer is choice A. So this was pretty quick, but in some other problem it could be the fact that you will have to check a few options before you find out which is true. So the first choice A is true. Let me quickly check if I am doing it correctly or not. 1 by 25 multiplied by 5 to the power n. 1 by 25 is 1 by 5 square. So we have n minus 2. Yeah, it is. Choice A is true. Which of the following is true? Okay. Okay. Problem number 11. If minus 4 by 9 whole raised to the power 3 is divided by minus 8 by 27 square, the quotient is. So basically we have to find the value of minus 4 by 9 whole raised to the power 3 divided by minus 8 by 27 whole divided by raised to the power 2. We have to find this. We have to find this. Okay. So so clearly we can see that we have we have to eventually convert these exponents into rational form, and the rational form, some terms in the numerators and the denominators will be in exponential form, and we have to convert all the bases to some similar bases. So we can clearly see that the base will be either 2 or 3. 27 is nothing but 3 cube, 8 is nothing but 2 cube, So 4 is nothing but 2 square and 3 is nothing but 9 square. So, but first of all, let's convert it into the rational form. Like we have to get rid of the division. So minus 4 by 9 cube, the division, this will be multiplied by the reciprocal of the divisor. The divisor is this. This was the divisor in the given expression. Now its reciprocal will be this. This whole raised to the power minus 1. So the concept applied is x divided by y is equal to x multiplied by the reciprocal or multiplicative inverse of y, that is y raised to the power minus 1. Now this is equal to minus 4 by 9 raised to the power 3 multiplied by minus 8 by 27. We have two levels of powers. First level is 2. First level of power is 2. Second level of power is minus 1. So this will be minus 8 by 27 whole raised to the power 2 multiplied by minus 1. This is equal to minus 4 by 9 whole cube multiplied by minus 8 by 27 whole raised to the power 2 multiplied by minus 1 is minus 2. Now this is this, and 8 minus 8 by 27 raised to the power minus 2 means 27 by minus 8 raised to the power 2. Why? Because we know that x to the power minus m is equal to 1 by x to the power m. Now we will break all the exponents. We will break the exponential terms into rational terms. That is, by that I mean, if we have x by y raised to the power m will be equal to x to the power m divided by y to the power m. So we have minus 4 raised to the power cube divided by 9 cube multiplied by 27 square divided by minus 8 square. Now the factors of the exponential terms with the negative base, that's minus 4 raised to the power 3, the power is 3, so this will be negative of 4 cube divided by 9 cube multiplied by 27 square, and we have minus 8 whole raised to the power square. So base is minus 8 is negative, but the power 2 is even, so this will be 8 square. Now so this number will be a negative rational number. As we can see, there is a negative sign, that is minus 4 cube. So let's put the negative sign at the very beginning, and we have 4 cube. Now 4 cube I can write it as 4, I can write 2 square and this cube. 9 cube, the base 9 I will write it as 3 square and cube multiplied by 27 square. 27 I will write it as 3 cube whole raised to the power square. Similarly 8 square I will write it as 8, I will write it as 2 cube and whole raised to the power square. I will need to convert, the idea is to convert all the exponential terms so that we have some similar bases. So this is equal to minus 2 square whole raised to the power cube is nothing but 2 to the power 6. 3 square whole raised to the power 3 is nothing but 3 to the power 6 multiplied by 3 cube whole raised to the power 2 is 3 to the power 6. 2 cube whole raised to the power 2 is 2 to the power 6. So these two get cancelled, these two get cancelled, and we got minus 1. We got minus 1. So minus 1 is the answer. The answer is choice D. Okay, let's do problem number 12. Which of the following can be true if ax equals to 0. Which of the following can be true if ax equals to 0? Oh, sorry, it is ax to the power 0 is equal to 0. This equation is given. A must be some constant. X raised to the power 0 is equal to 0. If this is true, then what can be, then which choices can be true? Now, choice A, let's see what is choice A. Choice A is saying A is equal to 0 and X is equal to 0. This will never be true because in exponents, the base is never 0. Whenever we talk about these exponents, that is terms in exponential form, x to the power m, x is a rational number, x is always a non-zero rational number. So in this equation, we see that it is a multiplied by an exponential term, that is x raised to the power 0. Now do not always remember that whenever you have some exponential term, the base is always non-zero. So in this problem, you do not say that x to the power 0, wherever you see power of 0, do not say it is 1. No, it is 1 only when the x base is a non-zero rational number. So choice A, x cannot be 0. So A is not true. Let's see choice B. What is choice? A not equals to 0. A is not equals to 0 and x is not equals to 0. If x is not equals to 0, then definitely this thing will become a into 1 equals to a. Why? Because if x is non-zero, then x to the power 0 will always be 1, because we know that for any rational number, any non-zero rational number, x raised to the power 0 is always equal to 1. So x to the power 0 will be equal to 1. So it's a into 1 equals to a. But it is also saying that a not equals to 0. This will violate the equation, because in the equation it is given that a x to the power 0 is equal to 0. So B cannot be true, because if B is true, in the equation will not be, this equation will not be satisfied. The right hand side will not be equals to 0. So choice B is also incorrect. What is C? A is equal to 0 and x not equals to 0. Let's see what happens if this is true. So A will be equal to, x is not equals to 0, fine. The base is not equals to 0, and we know this will be equal to a multiplied by 1. This is equal to a. This is equal to a, and a is also given to be 0. So this will be equal to 0, which is satisfying the given equation. The right hand side of the given equation is 0. So definitely C is the correct choice. So if whenever you find a correct choice with full confidence, you do not even you need not check the other choices. So I will not check the choice D, even though the choice D can never be true. No, that is a bogus choice anyway. So choice C is the correct choice. Answer is C. Okay, let's do problem number 13. Simplify. Okay, so it is a simplification problem and it looks a little complex. Okay, so it is 2401, this whole raised to the power 3 divided by 343, this whole raised to the power 4, and this whole raised to the power 2. Okay, now definitely we have to consider how do we convert 2401 and 343 in the exponential form. We have to convert these two numbers in the form x to the power m, and also 343 we have to convert this into the form, preferably if possible in the form x to the power some power n. If we can C 2401 can be a power of x, where x will be some integer definitely, and 343 can also be expressed as a power of x. Then it will be easier to simplify. Okay, so for that, let's do the prime factorization of 343. 343. Yeah, I can see it divides by 11. Okay, 333. No, sorry. No, sorry. 343. It does not divide with 3. 7. 7. Here. It divides with 7. What happened? Oh. 7 it divides 4 and then 9. Okay. 7, 7, 7, 1. So definitely I can see 343 is 7 raised to the power 3. So definitely I am predictably 2401 will also can be converted into some power of 7. So let's see, 2401, let's divide by 7. Will it divide by 7? 3, 21. No, it is not dividing by 7. What is wrong? 7, 3, 21, 3. Oh yes, it is. 7, 3, 21, 3, 4 and 4. Okay. What is happening? 3, 21, 3, 4 and 3. Oh, okay. So 343. So definitely this will be 49, 7, 7 and 7, 1. So 2401 is nothing but 7 to the power 4. Oh, okay. So great. So this is we can now write it as 247. 2401 is 7 to the power 4, and this is whole was raised to the power 3. We have divided by 343 is 7 to the power 3, and this was whole raised to the power 4. We have this division, and then this division is raised to the power 2. Okay. So this is equal to now 7 raised to the power 4, and again that raised to the power 4, we are having two levels of powers, 4 and 3. So this will be 7 raised to the power 4 multiplied by 3 divided by 7 again raised to the power 3 multiplied by 4 square. So this is super easy. Now we can see that this is 7 raised to the power 12 divided by 7 raised to the power 12 whole square. Now this is nothing but 7 raised to the power 12 divided by 7 raised to the power 12 square. This is nothing but 1 square. 7 raised to the power 12 divided by 7 raised to the power 12 is definitely 1. So 1 is the value, and the correct choice is choice C. Okay, let's do problem number 14. We have to find the multiplicative inverse. In short, I am writing MI. Do not consider it as a, don't think this is mission impossible. This is multiplicative inverse. Multiplicative inverse of 5 by minus 9 whole raised to the power minus 99 is multiplicative inverse of this is nothing but you know that if you have something like this, x by y, where x by y is the rational number, we have some power m, whatever, that m could be positive or negative. A multiplicative inverse of x to the multiplicative inverse of x by y whole raised to the power m is nothing but you, the reciprocal of the base, that is x by y, you interchange the numerator and the denominator, that is it will be y by x whole raised to the power m. So in this case it will be minus 9 by y whole raised to the power minus 99. Now you should be very careful what are the choices given. In the choices given, everything the power is 99. The power is 99, but we have the power is minus 99. Now, if I want to make the power 99, what do I have to do? I know. So this is where some trick will be required. So I know that minus 9 by 5, the power 99, and can write it as 99 multiplied by minus 1. So this is, I can rearrange, I can write using the formula, using the laws of exponents, x to the power m, this when whole raised to power n is equal to x to the power m into n. So given the left hand side, this one I can write the right hand side. Conversely, reversely, if I have this, I can write, I can express it as the left hand side. So I have in the power 99 multiplied by minus 1. So I can write it as minus 9 by 5 raised to the power minus 1, and then this whole raised to the power 99. Meaning, if you have, you can always write x to the power m and then whole raised to the power n as x to the power n first and then this whole raised to the power m. You can always rearrange the powers like this. Now minus 5 minus 9 by 5 raised to the power minus 1 means the reciprocal of minus 9 by 5, that is 5 by minus 9, and we have raised to the power 99. So now this becomes 5 by 9, the 5 by 9, the base rational number 5 by 9, you can write it as, if you make the denominator positive, it becomes minus 5 by 9 raised to the power 99. So this is the answer, and we can see it is matching with the choice A. Okay, let's do the last problem, that is problem number 15. Problem number 15. Express 1296 divided by 146441 as the power of a rational number. Okay. So this is also a typical kind of problem where you will be given a rational number in the form p by q, where p and q will be some very large numbers, and they should be able to express as a power of some numbers, power of some integers. So in this case, the numerator is 1296 and the denominator is 14641. If you have to convert a given rational number, so the idea is, if you are asked to convert a given rational number, let's say x by y is a given rational number, to the form of some rational number z to the power m, where m is some integer, then you can only do this if you can convert individually the numerator and the denominator of the given rational number as an exponential form with some base, let's say a and same power. If you can convert both the numerator and the denominator of the given rational number in exponential form with the same base, not same base but same power. So essentially, you have to convert a given rational number x by y in the form of exponential form, which will be, say, z to the power m, where m will be some integer and z will be some rational number. Now, for this, if you have to do this, then obviously you must be able to express the numerator and the denominator, both of them, as a power where the power will be same. Let's say you can the x might be able to be expressed as an exponential form a to the power m and y as b to the power m. The power should be the power should be same. Only then we can say that x by y is equal to a to the power m divided by b to the power m, and this is equal to a by b whole raised to the power m. So this is the exponential form. So let's see if we can. So for this, how will you express 1296 as the power of something? You have to do the prime factorization of 1296. Now the power has to be same. Okay. Okay, I can clearly see it is dividing by 3, so I will divide by 3, 4, 3, 2. Then what? Again I can see it divided by 3, so 1, 4, 4. Okay, so I can see 3, I can see 4, 48. 3, 16. Okay, I see. And then I know 16 is what? Okay, so 129, 1296, I can see if I do prime factorization, I see the factors can be expressed as 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 16. Now this is equal to how many 3's we have? 3 to the power 4, and definitely 16 is 2 to the power 4. 2 to the power 4. So this we can write it as, so it is 1296 can be expressed as 3 to the power 4 multiplied by 2 to the power 4. This is nothing but 3 multiplied by 2 whole raised to the power 4. This is 6 raised to the power 4. So another concept, a good concept, is that whenever you have something like x raised to the power m multiplied by y raised to the power m, product of two exponents where both the exponents have power same, then the result will be the product of the bases, that is x into y raised to the power common power, that is m. So this is 12966, 6 raised to the power 6 raised to the power 4, 6 raised to the power 4. Now let's see what is the prime factorization of 14641. Will it divide by 7? No. 9. 24. 9. 5, 56, 54, 24, 18, 6, 61. No. 11. Okay, one thing you can clearly see that we have found that 1296 always in many cases the choices given can give you some hint how to solve the problem, or what could the answer be. So you can, in the choices you can clearly see the numerator, in many of the choices the numerator, we have the numerator and the denominator is either 6 or 11. So we have found definitely 1296 is the power of 6. So definitely this 14641 has to be some power of 11. So definitely it will divide by 11. Definitely. So let's see. 1, 36, 3, 33, 3, 33, yes, 3 and 1. Okay, again it will divide by 11. 1, 23, 2, 1, and this we know is 11, 11 and 11, 1. So 1461 is nothing but 11 to the power 4. 11 to the power 4. Now let's show the 1296 divided by 14641 is equal to 6 to the power 4 divided by 11 to the power 4 this will be equal to 6 by 11 whole to the power 4. 6 by 11 whole to the power 4, and so the correct choice is C. So this brings to an end of solving the first sample paper, test paper number 1 on the chapter of exponents. These problems are good enough to test your or evaluate your understanding of the concepts of the chapter of exponents, that is laws of exponents, and whatever topic we have discussed. Numbers in standard form, expressing large numbers and small numbers in standard form, and simplification, solving for x where x will be in the power of some given equation. So all these kind of problems, reciprocals, simplifying, multiplicative inverse, and all the laws of exponents. These problems will give you a good set of problems to test your understanding of the concept. There will be another test paper tomorrow, sample test paper number 2 of similar kind, and two test papers are good enough to check your understanding of the chapter concepts. So I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, so the next video will be on solving the sample test paper number 2, and the link of the PDF of this sample test paper number 1 will be given in the description below. You can check that out, but always try to solve the problems yourself. If you are stuck at any problem, then you can always see my this video for the solution as a reference. So thanks for watching, and until the next video, take care and bye.